Welcome to the spermatogenesis tour. This tour will take you on a journey through the testis. Remember, if you get stuck, touch the back seat of your vehicle. We will explore a seminiferous tubule and learn how the anatomy and physiology interact to regulate sperm production. This is an overview of the testis. The testis is covered by a relatively thick connective tissue layer called the tunica albuginea. Let's look through the tunica to the inside of the testis. The main functional unit of the testis is the seminiferous tubule depicted here in green. Each testis is comprised of about 1,000 of these tubules. Sperm, depicted as fluorescent green particles, are released into the lumen of the tubules. They float through the tubule toward the common collecting ducts called the reedy testis, depicted here in red. We will now enter the tubule to see how sperm are produced. You will probably want to switch to mouse look, escape, escape, M. We are now inside a tubule. We will be moving left and down. Surrounding you are the tails of sperm attached to the cells lining the tubule. Flying by your head are mature sperm that are traveling down the tubule toward the collecting ducts. This corridor will take us to a higher magnification of the tubule. This is the entrance to a single seminiferous tubule. The tubule is surrounded by a basal lamina glowing white. Under the basal lamina are sperm stem cells called spermatogonia, which I have colored blue. They will differentiate into primary spermatocytes, which are red, which will differentiate into secondary spermatocytes, colored pink. These secondary spermatocytes will differentiate into spermatids, colored cyan. Spermatids differentiate into mature spermatozoa. Sertoli cells, the tall gray-white cells, nurture the sperm as they develop. Note the red parts connecting the Sertoli cells. These are tight connections between each Sertoli cell that are important for normal sperm development. We will see why in a moment. As the sperm mature, they are released into the lumen of the tubule. The sperm travel down the tubule and out of the testis. It is important to note that the sperm are not actually swimming. They are still immotile. The sperm travel down the tubule and out of the testis. It is important to note that the sperm are not actually swimming. They are still immotile. They move down the tube by mass action. They float downstream. They acquire the ability to swim once they leave the testis. Now we will travel between Sertoli cells. Mouse look, escape, escape M, is fun for this part of the tour. Normally, these spaces would be filled with sperm in various stages of development. However, in patients with Sertoli cell-only syndrome, they only have Sertoli cells. They are azoospermic, meaning they have no sperm. We will now look at the tubule from the other side to examine the relationship of the blood vessels and the developing sperm. We are now outside the tubule. However, in real life, we would still be inside the testis. Note that the blood vessels, as well as some cell types, such as the orange-brown colored lighting cells, are outside the tubule. Therefore, all products of the circulatory system, including antibodies and hormones, must pass through the basal lamina to get inside the tubule. However, the basal lamina is not the ultimate barrier separating the circulatory system from the developing sperm cells. Can you see the red, tight junction connections between adjacent Sertoli cells? I'll make the tubule transparent so you can see them better. These tight junctions form the ultimate barrier to keep many products of the immune system, including antibodies, from getting into the lumen of the tubule. Note that the blue-colored spermatogonia are under the basal lamina and thus inside the tubule, but they are separated from the rest of the developing sperm by these tight junctions. Let's go see how these tight junctions are involved in sperm development. Your tour will momentarily